last time we did series and sequences, we talked specifically about arithmetic sequences, which is when we repeatedly add a certain number. So our first example here for recursion is an arithmetic sequence where we repeatedly add the same number. And so we're asked, well, what's the next thing? And we find 10's the next thing. As we take a look at the second example, we see that it's not repeated addition, but if we take a look at our pattern, we quickly see that we're multiplying by 2. That's called the geometric sequence. But the idea of recursion is we base our next term off the previous term. So if I go back to this first example, I take a look at the 10, and I apply my pattern. I'm like, okay, plus 2, and that gives me 12. And when I want to know the next number here, I take a look at this number, and I say, all right, times 2 is 48. And then I keep on doing that, and that's what recursion does. So a recursive formula, to find the next term, what we do is we use the previous term. So let's take a look at an example of a recursive formula. So it has several parts, and its complexity greatly depends upon what we're doing. So let's take a look at this recursive formula. All right, so here's the recursive formula. Now let's dissect the little parts right here. So this A just tells me that I'm dealing with a sequence. So this little subscript here tells me the term number. And in this case, I'm being told that this is term 1, and that term 1 equals -4. So when I go back up to these, this would be term number 1, this is term number 2, this one's term number 3, and this 10 would be term number 4, and this 12 would be term number 5. And then this would just keep on going and going forever. And same thing here. This is term number 1, term number 2, and so on. All right, so I'm going to take a look at this, and what I want to know is, well, what's the next term? And the way this one's written, if I wanted A2, it says A1 plus 5, and that gives me 1. But the way this particular example is written, if I did A3, well, look where it starts. It starts yet again at A1, and I would just get a 1 again, which isn't really what we're looking for. So we want it based upon the previous term. So let's take a look at a better example. So let's say we have A1, and we'll start with that -4 again, but I'm going to write it a little bit differently. And instead of writing A1 right here, I'm going to write A sub n minus 1. And now I'll write my plus 5. Let's take a look at what this means. So if I wanted term number 2, so that means n equals 2 because I'm talking about term number 2. So when I go to this part right here, well, I'm saying n is 2. All right, so 2 minus 1, that's 1. And now I just so happen I know this. The first term's -4. And it looks similar to the previous example, but there is a very important difference here. So I get a 1. Now, did I get that the last time? Maybe I didn't get that the last time. Let's see. Yeah, I did. Okay, good. Okay, so now I know what term number 2 is. So I'd say term number 2, that's a 1. And I could even keep a list over here. All right, I have -4. I have 1. Now let's see what's next. What if I wanted term number 3? All right, so if I want term number 3, that means n is 3. And if I go into my formula here, this is the formula that I'm given, n minus 1. So that's 3 minus 1 plus 5. Now let's take a look. A sub 3. 3 minus 1, that's a 2. And, well, A sub 2, that's term number 2. So the -4, that was term number 1. The 1, that's term number 2. So what do I put here? A 1. And now I get term number 3 is 6. So 6. All right, let's say I wanted term number 4. So hopefully you catch on to the pattern here. It would be the previous term, which is the third term. And the third term is a 6. See, 6. That's the third term. And 6 plus 5, that's 11. So that's the next one. And then this would just keep on going. So let's unpack this a little bit. Let's take a look. So when I wrote that formula, it looks something like this, right? And what does this mean? Well, this is the term I want. And n, that is the term number. Well, then what is this piece right here? Well, that is the previous term. So the one that came just before it. And this 5 just tells me what I'm doing. So let's try a different recursive formula. Let's say I say a sub 1, let's say that is negative 3. And let's say a sub n is a sub n minus 1 plus n. Now this is a lot different than the example we just did, because this number that I'm adding is going to keep on increasing. So let's say I wanted to find term number 2. So this piece right here, that's simply the previous term. So the term that came before term 2 is term 1. Now, I want term number 2. So what does n equal? Well, n equals 2. So what am I going to add to term 1? A 2. So term 1, I knew, that's negative 3. And negative 3 plus 2, that's negative 1. So now if I keep my list, and I'm going to want to keep a list, so negative 3, that's term 1. Negative 1, that's term 2. This is number 1. This one's number 2. All right, let's say I wanted term number 3. So term number 3, that means n equals 3. And my previous term, well, that's a2. And n is 3. Now look at my formula I was given. I'm going to add my term number, and I want term number 3, so I'm going to add a 3. All right, a2, I just found, is negative 1. I'm going to add a 3 to that. That's 2. So term number 3, that's 2. Term number 3. Let's try one more. A sub 4. So the previous term was a 3. And now, well, what's my term number? So take a look at my formula here. I'm adding the term number to it, and I want term 4, so I'm going to add a 4 here. So a 3, I just found that out. That's a 2. And I get a 6. So term number 4 is 6. And this would just keep on going. And hopefully you see this pattern that has emerged here. I added 2 to get here. I added 3 to get here. And I added 4 to get there. And that gives me my recursive formula. All right, so let's take a look at one final example, I suppose. Okay, so let's take a look at this. Now, what does this mean? Let's unpack this. So this is the term I want. And this is the previous term. And this right here would be back 2 terms. So I already know A1 and A2. So I have 1, 2. And now what I'm doing with these, I'm adding. So if I wanted term number 3, I would take term 1, or the previous term. So 3 minus 1, that's 2, plus. And then see my term number, I want n is 3. So this would be 3 minus 2, so that's A1. Now I'm going to add these two. Well, what was A2? 2. Plus, what was A1? 1. So I get 3. So 3. Let's say I wanted A4. All right, well, look at this formula. N minus 1, that's 3, because my n is 4, plus n is 4, so 4 minus 2, that's A2. So I'm going to add the previous two terms. So A3 is right here. That's the third term, 3, plus the second term is 2. So what do I get? 5. So my fourth term is 5. So hopefully you can see what's coming next. 3 plus 5 is 8. Let's just make sure that that's correct. So A5, so my previous term then is A4, and 2 terms back then is A3. So A4 is this one, and A3 is this one, and I get 8. So let's try one more, A6. So hopefully you see right away, 5 plus 8, 12, not 12, 13. We expect 13. So if I want the 6th term, the previous term is A5, and the one even further back is A4. And A5, that's 8, and 5, 13.